Hey, what's up everybody? It was a while ago I made a video. There was a lot of stuff going on in the university, but now I have got some time and let's begin with new projects. Here I have built together a coil gun, and this coil, here's the coil, the gun assembly. I calculated the coil with some formulas and stuff, so I can get the most power out of it. And this is the bullet we're going to use. And yes, the bullet is calculated in that. And the tube fits perfectly to the bullet. It's just a little bit, nearly 1 millimeter larger. So it has a nearest contact with the coil. That's good. So it's pretty efficient. We got 3 capacitors, 8,800 microfarads. We're going to charge it up to 320 or 340 volts. And there's SCR, and dump all the energy, which is around 500 joules, into that. And let's see what kind of carnage we get. Ballast transformer or ballast choke for charging the capacitors. There's the full bridge rectifier. And yes, let's turn it on and see what happens. Here you can see we got a voltmeter. I'm going to put a lead acid battery right here, because it's going to be a lot of recoil on that gun assembly, so it will fly away. And I'll put this box like a target in the front. You can see that I shot a couple of times. I put it like that, so you can shoot here. I put this box in front of it just because I don't want the bullet to fly around this room after I've shot. So yes, let's charge it up. Yes, that's good. And I'm going to trigger the SCR and dump all the energy stored in the capacitors to the coil. You can see what happened. The bullet hit this place here, and was trapped in this box. And you can see where the gun assembly is. That's a lot of recoil on that. I'm actually charging the capacitors from the variac over there, so I can go a bit over voltage. I'll plug it in again, charge it up, maybe a little bit more. Yes, a little bit more than that. So 340 volts, and 350 volts. Let's shot it. So it hit over here. The coil is not so warm. Most of the energy is actually dissipated in the bullet to get it some velocity. So not so much energy is actually wasted as heat. In the secondary school, we used to build this kind of stuff on the art lessons. This is pretty old. I have a lot of these houses. This is a bit burned, as you can see. There's a hole in the roof as well. So I'm going to try to shot with a coil gun and see what happens. It's right there. I put the lead acid battery closer to that. So triggering. This is punctured pretty good. There's a lot of glue on this. So let's shot it one more time. Great. And one more time on the front. Yes, that's pretty high power there. Let's drive the circuit board. So I think it hit the back there. It didn't damage it, but the chip has begun to come off. So that's how you actually can do to get these integrated circuits or chips out. Just shut it and it will jump right off. Looks fun how they budged the transistor in there. And now time for a microwave oven capacitor. This capacitor is already damaged. It's shorted out, so I'm gonna throw it out anyway. The protective box on the front. Here you can see. It's pretty good. I think it's actually punctured a hole in there. There is some holes from previously as well. I shot it a couple of more times. But yes, this was the hole I shot now. And the bullet is wrapped in the box instead of flying around the room. I have full range on the variac, so let's see how many volts that will be. 370 volts. That's nice. Let's see if it's more efficient at this voltage. Maybe. Oh, I missed it. There's some scratches there. Damn it. Another try. Maybe this time. Yes, I think I hit it. It's up here. And you can see it's not as deep as the previous one. So at this voltage it gets less efficient. It's actually rated, I've calculated 340 volts. If you put 370 volts, it gets less efficient. So at this point I actually have to have a larger coil or have this a little bit longer, because the bullet must be a certain amount of length from the center of the coil. Not so warm yet. So I hope you enjoyed it. Thanks for watching.